পরে ফোন করো, ক্লাস নিচ্ছি। Okay, good afternoon to all of you. I hope that my sounds are coming properly. Kindly, any one of you kindly respond to my WhatsApp that my sounds, audios, these are coming properly. Any one of you kindly respond to me so that I can start today's session. Those who are viewing, anyone please reply to me personally in my WhatsApp so that I can start the session. Audio and video sounds properly are coming. I am waiting for your responses. Any one of you please respond. Those who are viewing, anyone please respond that audio and video, these are coming properly. Okay, Joy. Okay, thank you. I got your response. Thank you, Anand. Thank you, Joy. Got your response. Okay, so yesterday I So yesterday we have completed some part, that is in file organization. Okay, thank you. Those responded, please, thank you. Aditi, thank you. Okay, now focus please. Yesterday we have discussed so many parts in our file organization chapter. Okay, I just going back to the last slide. In records or in file organization, there are different types are there: heap file organization, sequential file organization, multi-table clustering, B plus tree, and hashing is there. Total 5 types are there. So in between this we already discussed the heap file organization and the sequential file organization. Okay, now we are going to focus on the multi-table clustering file organization. These are quite important because depending on the multi-table clustering file organization, we are mixing the data. So now the example is looking like that. For example, if you are considering a table department, 3 fields are there: department name, building, budgets are there, and some data values are already inserted in this table. And again you are considering another table, that is instructor, and in this instructor table total 4 fields are there, and some data contents and data values are inserted. Okay, now when we are merge up this table, we have 2-3 types of scenarios. How we can merge up these things? We can use joining operation. Some left outer join operation can be possible, right outer joining operation can be possible, inner join operation can be possible, or fully outer join operation can be possible. So here the inner join is possible in some ways, that where department name is matching, then we are going to fetch this data. Okay, and in case of a fully outer join, we are not going to check anything, we are just simply adding the data into row column multiplication format. Okay, now apart from these things, in case of a joining, we need at least one attribute should be matched in both of the table. So in both of the table, if you are checking that department name is the common column, so depending on the department name, you can go ahead with the fully outer join, inner join, left outer, right outer, any type of a joining operation. That is a different scenario. But if you want to put your data in as it is format according to the table, means in department table only 3 fields are there and in instructor table only 4 fields are there. If you want to keep this data in as it is format, then what will be the scenarios? The scenario is this: you may copy the data from both of this table and put this data in a new table or in a new file in the same format. Okay, so when you are pasting the data, so in your new file, probably one record structure is different and another record's structure is different. In simply meaning, for example, in first row, if you are checking in the first row, only 3 values are there, and in the second row, 4 values are there. Again in fifth row, 4 values are there. Again in the next row, 4 values are there, and in this fifth row, only 3 values are there. So there is no as such similarities. From this table structure, you are not going to take any similarities in the fields, because in this first column the data values are in mixing order. In the second column, you can't understand that what is the actual meaning of these values. Okay, so it's looking like that. Now the thing is that this type of structure is sometimes important when you want to keep the data in a single block and you want to put the data and store the data for future purposes. Okay, so for example, when you mix all the table and put the data in a single Excel file, then you must have some kind of a benefit. The first benefit is that it reduces the IO operation. It reduces the IO operation, meaning is that if you distribute this data and save in another file, in different file in Columnar format, according to the column, if you are maintaining a separate file and then you have a number of files, and when you are searching a particular data values, every time you are searching the same operation in each of the particular file. So then the cost of the query or the number of IO operation is quite maximum. But if you are searching a particular file in a single block, then your search result will be optimum, and as well as the cost of the query is quite minimum. Just a simple example: in an Excel file, when you are searching a data, you mainly use the keyboard command, that is Ctrl F. But if you are searching the same data at least in 4 or 5 file, then you need lots of IO comparative to the first cases, and the cost of the query is maximum in that cases. So sometimes the multi-table clustering, file organization concept, or the mixing of the data, or this kind of approach is quite helpful to search the data in perfect time. So there are a number of kinds of a benefit. This is not the actual joining operation. This is beyond the joining operation. Okay, bad for queries involving only department. So if you are saving only a particular department values only, then it is cost is quite maximum. Okay. And records, obviously in this type of a file format, each of the records or each of the row size is quite different comparative to each other. Okay, and for searching purposes, you can add some pointer values in the record. How you can add the pointer values? For example, in the first row, you are taking these records from the first table, and in the second, third and fourth rows, these particular rows are belongs from the second table. So data item or the records that belongs to the first table, and records or rows that belongs to the second table before the records, meaning is that at the insertion of this particular records or at the end of this any of the particular record, you may add a specific pointer that is denote to the particular table. For example, here the first row is belongs to the first table, so here you can add a pointer that is 1, and when next time when you are fetching the second rows from the first table, then you can add a pointer like 2. So using this pointer from a mixing of a table, using this different kind of a pointers which are located to the specific table, you can get the benefit. Okay, So the next thing is that column oriented storage. Okay, this is the type. This is the type of a multi-table clustering file organization. For the multi-table clustering file organization, the first example is the column oriented storage. Column oriented storage meaning is that is a very simple thing, that you have a table and the table is consist of ID, table is consist of a name, table is consist of department name, and table is consist of the salary of the employee. Now what to do? Now the things it's like that you divide the table in column wise. You divide the table in column wise means you break the table in 4 part. The first table holds the first column values, the second table holds the second column values, like that. So now a single table is divided in 4 table depend on the column position. Okay, so this is the kind of a thing where you can fetch the data depend on your search keys. Meaning is that for example, from a whole table when you are searching, for example you are searching like biology. Now check the position of the biology. The position of the biology is at the first, second, third, fourth, fifth, sixth, 7, 8, 9, 10th as the 10th row, and the column position is 3rd. Okay, now very good. Now the thing is that from a compact table when you are searching, the main problem is that if your table size is quite maximum, for example 10,000 records are there, and each of the records holds 10,000 records are there, and each of the records for example have 5 fields or 5 attributes. So how many cells are in your file? There are 10,000 into 5 means total 50,000 cells are present in our file. So if you are searching a value, if you are searching a particular cell values that are at the end position, meaning is that at the position of 49,999th position. So when you are searching this value and this particular values are distinct in nature, if these particular values are distinct in nature, or if these particular values are replicated, then what will be the problem? The problem is that if you are using the linear search or the sequential search kind of operation or some binary search kind of operation in this particular table, then you go to row by row or column by column operation. So at that time the search means the cost of the query for the search is quite maximum because the particular values are at the end position. If you are go through column by column means first you check the first value, second value, third value, like in this shape in U kind of a pattern, then you are fetching this value after long time. Again, if you are searching this value by row searching operation means through the sequential search, then it is also takes quite maximum time. So the helpful method is that you divide the whole table in according to the column, means in a single table only similar type of data contents are present. Okay. Now when you are searching the biology means you got the information that we are fetching for the department only. Then you directly go to the department table, and in this department table you search the values, that is maybe from the starting position, maybe from the ending position, or maybe depend on some binary searches method. Okay, so here the cost of the query or the minimization of IO is quite less. Okay, so that's why we prefer sometime this kind of a structure, that is column oriented storage structure in multi-table structuring concept. In modern operating system, this kind of things are basically used. Okay, so what is the benefit of these things? The benefit of this, obviously reduce the IO operation, improve the CPU performances. Obviously whenever the IO operation is minimized, the primary memory utilization is quite less and it is speed up. So obviously your CPU cache performance is increased. Improve the compression as well, and as well as the vector processing LOS. Okay, but there are some drawbacks as well. What is the drawbacks? Drawbacks is that the cost of the tuple reconstruction from the columnar representation, means when you are going to create a single tuple, or whenever you are going to fetch a single records, then it is quite cost of the query is little bit maximum. Cost of the tuple deletion and update. If you want to delete a single tuple, means if you want to delete a single row, then the operational cost is quite maximum, because you have to delete the same thing from 4 of the table. Okay, so that is a problem. Cost of the decompression is obviously little bit higher. Okay, so there are some benefits and some drawbacks are there. Okay, now we are focusing on some new part, that is some specific things are there. Traditional row oriented representation preferable for transaction processing. Yes, we know that thing. Okay, so now the thing is that depend on the multi-table clustering approach. We focus on the Columnar file representation. So depend on the Columnar file representation, some modern operating system use this kind of a file distribution system in their basis. Okay, so two Columnar file representation types are there. First one is the ORC, second one is the Parquet. ORC is ORC means that optimized row columnar format. All of you please note down the full form, that is ORC means the optimized row columnar format. Optimized row columnar format basically used in the Hive engine, Hive engine. So Hive engine is basically a core part of the Apache server. In Apache, basically we are using the Hive file format. In Hive format, the main representation type is the ORC, or the optimized row columnar format. Okay, and Parquet data format is a different kind of a format. Parquet is basically used in a Hadoop, in big database operating system. In Hadoop language, basically we use the Parquet data file format. Okay, so in Hadoop there are a mixing type of a columnar representation are there. Basically we are using the Parquet file format. Parquet file format is like a file format, for example, that whenever you are fetching the data from the Twitter or fetching the data from any raw sources, your data basically are in a notepad file, in JSON file. Okay, you not known about the JSON file format. JSON file format means a raw file format. We just simply fetching the data from the Twitter. Okay, so in JSON file format, whenever you extract the JSON file format in notepad file, so that is in a scattered order. So from the notepad, if you select all the data content and paste it to the file, then you got the file in different number of columns are there. There are multiple, near about 1000 columns are there, and there is no as such similarities. For example, in first column, one name is there, in second column again name is there, some blank spaces there, means it's a total scattered order. Okay, so from this scattered order we are break this file, then we are depend on some algorithm, we are going to check the data similarities. So Parquet type of a file is a similar kind of a file. Okay, now in ORC and Parquet, the file format with Columnar storage file format. Okay, very popular for the big data application, obviously, as I already discussed. ORC file format is useful in Apache server, in Hive engine basically. Okay, so basically what is the Columnar file representation? In Columnar file representation, first we are start with the index data. It means first index is there in column, then in second row in a single column, row data or the row information is there. Next is the stripe footer, means the ending position. Okay, means the ending position, means the column is ended here. Okay, next again second stripe is there, and like in the similar order all the stripes are connected. And in the index data part, in a single stripe, in an index data part, there are number of column indexes are there, that whatever row data are stored in a single stripe, how many columns are there, and for each of the columns index value are stored here. Again the same thing is in your row data. In your row data, for the particular index values, the similar row information are presented, and for ending of the file, we are here marked with the stripe footer, means from this stripe the data content is finished. So here the stripe meaning is that, for example, it's looking stripe means here a single file data can be presented in this columnar format. Okay, so next is the structure, that is when you are considering a table, here in this particular format a single stripe is added one by one in a single column and maintained the whole table structure. Okay, so column-oriented storage can be quite useful for memory management as well, and its compression reduces the memory requirement. Obviously, here the compression is there, that's why it's obviously requires the memory quite less in comparative to the normal file structure. Okay, so these are the basically about the file organization structure. Okay, so yesterday we have discussed the file organization. Now I am going to recap that thing. So here in file organization we already discussed records, okay, files, values, this kind of a thing. Fixed length file structure is there, variable length file structure is there, some file records structure is there. We already discussed heap, sequential, multi-table record structure. Okay, B plus tree, we are going to discuss B plus tree in next session. Okay, so this kind of things are there. These are the basics about the file organization. Now we are going to the ending part, that is on the indexes. Okay, that is on the indexes. So file organization is complete. Now we are focusing on the indexes part. Okay, now we are focused on the indexes part. So in indexes part, whenever we are going to check, meaning is that it is very simple. Meaning is that whatever file format you are using, that is not the main important thing. Main important thing is that for each of the file and within the file, for each of the record, some kind of a index should be there, because depending on the index the searching is quite easy. For example, if you are maintaining a library, whenever you are visited a library, what is first what you have seen? The main thing is that at a central storage, that can be considered as a hard disk. At a hard disk, different blocks are there, means different drives are there. So whenever you are entering, you can see that thing, that there is different rack or different almirah for different subjects. Means for example biology, for example economics, for example computer science, for example electrical, for example humanities, like that. Different rack is there or different almirah is there. Now the thing is that within this particular file, if you are going to the computer science segment, means in computer science rack or in computer science almirah, you check there that there are different row is there. Row is there means if you open the almirah, you can see there are total 5 rows or total 6 rows. If you visited the computer science rack, you can check that thing, there are total 6 or 7 rows are there. So here within a file, each of the row is considered as a records. Okay, so now the thing is that within a almirah or within a rack, you can check that for each of the rack there are some index values are there. For example, in first rack, the book of database management. In second rack, the book of operating system. In third rack, the book of computer networks, like that. Okay, so now if you are entering in a single row or in a single rack, then you can get that in each of the rack there are number of books, or in each of the row there are number of cells in actual records. In a single row there are number of cells are there. So here in each of the rack there are number of books of the there. So for each of the for each of the book there must be some indexes, that is starting from some alphanumeric number or starting from some particular assigned code values. Again here in our file format, in a single row, whenever you are finding the cell or whenever you are finding the fields, whenever you are finding the attributes in a single row, for each of the cell you must have some kind of a index value. So this index value is very important to search the particular books or to search the particular values from the whole table. So now if a single books have a particular ID number or have a particular code number, then from the library you can easily fetch the particular books using some search key option. Same thing in your file, if an individual cell or if an individual attributes or if an individual blocks have some index values, then the searching operation is time is really required very less. So that is the main benefit of the indexing. Now we are going into deeper of the indexing, that in indexing there are some kind of a concepts are there. Okay, some order indexes concepts are there, some multi-level index concepts are there, some secondary level index concepts are there, and some modern level index concept that is considered as the B tree, B plus tree concepts are there. And the most efficient indexing concept is that basically we are using still now, that is the hashing operation is there. Okay, so hashing operation is there. So today we are going to discuss some of the basic concepts, about the indexing. Okay, tomorrow you have a lecture of Srilekha ma'am. Okay, tomorrow you have a lecture of Srilekha ma'am for first 4 section, probably from third lecture or from first lecture, and for rest of the section in another slots. Okay, I request to all of you, please don't miss this lecture, because ma'am are going to discuss B tree index file and the B plus tree index file concept in this lecture. Okay, so please don't miss the lecture. Okay, now we are going to discuss about the basics about the indexing. So in basics about the indexing, first we understand that indexing mechanism used to speed up the access of the desired data. Obviously, I already gave an example that whenever you are visiting the library for a particular book, there must be book name, author name, some info, some kind of a RFID tag in this book, or for example, some barcode is assigned with this book, or some index number is in this book. Okay, so using these things, the searching of the particular book in your library, that is quite easy. Okay, now what is search key? What is search key? Search key means here the search key, the barcode, the RFID tag that is assigned to your book, that is considered as the search key. So what is search key? Search key meaning is that search key is considered as an attribute or a set of attributes that's used to look up the records in a file. Means a particular value is, or a particular attributes from a records is assigned as a search key from the whole file. So what is index file? Index file is a file that is nature is quite like the normal file. Index file is like the normal file. So rather, instead of saving the records, here the index file maintain 2 fields. First one is the search key and the related pointer. Means you are just maintaining a separate index or catalog for all your books. Okay, meaning is that if you have a DBMS book, in DBMS book there must be an index is there. So in this indexes, what is the values are there? Sir, some chapter information is there, and for subchapter some topics are assigned, and for each of the topics section is defined, and for each of the section the page number is assigned. So meaning is that here the index file is a kind of a file where this kind of index information are present. So 2 things are present here, the search key and the pointer. Means what is the search key for the particular records values, and what is the pointer values? Means depending on the search key, a particular pointer is assigned, that this search key is located to this particular record. So one pointer is used to point the particular record that is concurrent or that is connected to the particular search key. Okay, so that is index file consists of number of search keys and number of related pointers. 2 fields are there. Okay, so 2 kind of indexes are there. First one is the ordered indexes and second one is the hash indexes. In ordered indexes, all the search keys that are stored in index file, that is in a systematic order, or that is in sorted order, maybe in ascending, maybe in descending, or some other kind of order. And in hash indexes, the search key is generated by some hash function, and that is most useful. That depending on a hash function, the particular search key is generated, and this search key is matched with the search key in index file. Then you go to, using the pointer, then you go to the actual record or the actual rows. Okay, so hash indexes are quite useful. Next is the concept that what is the index evolution matrices. Index evolution matrices. Index evolution matrices meaning is that how you can find that which indexing method is useful. So whenever you are measuring some performances, you need at least some of the parameters. If I am saying that total 5 students are there, that which students is efficient and which students is best, then how can you judge that thing? You must select some kind of a parameter, that what is the grade point of these students. That is the first thing. Second thing is that, for example, what is the marks of the mathematics in 12th class for all the students. Okay. Third parameter is like that, for example, what is the marks of the English language in their higher secondary exam or in their 10+2 exam. Okay. Fourth parameter like that, what is the handwriting type, this kind of a things is there. Same here, whenever you are judge the best index file, that which index file technique is best, then you need some kind of a evolution matrices. So the first evolution matrix is the access type. Access type that supports the efficiency, meaning is that what type of access methodologies you derived in your index file. So here, whenever you are considering that efficient access type method, so efficient access type method must have some kind of a scenarios. First thing is that record with a specified value in the attribute, means in the attribute, means in the search key attributes, there must be some kind of a specified values, and there must have some kind of a range of the values. And apart from the access type, some index evolution metrics are like the access time, what is the minimum access time is required. Insertion time, if you want to index a new, if you want to add a new entries in your index file, then what is the insertion time. And if you want to delete a index from your file, then what is the deletion time. And how many buffers you have, means what is the size of your free pool in your indexes, means if any new chapter or any new index is inserted, then how many space overhead is there. And space overhead means one thing is there, for each of the indexes how many space you are allocated. So if you allocated a minimum space for each of the indexes, then it is quite efficient. So these are the index evolution matrix that is quite helpful to judge the best methods. Now we are focused on the order indexes. In order indexes, the concept is like that. In order indexes, all the string index entries that are added in your index file, that must be in a sorted order, maybe in ascending order, maybe in a descending order, according to the search key sorted order. Next is the clustering index. In clustering index, there is some sequential structure is there, means here the index file is sequentially connected by a order, and in each of the indexes, the search key specify the sequential order of the file. Okay, so sometime the clustering indexes can be considered as the primary indexes, means each of the indexes are connected with the previous index and with the next index, like the sequential file organization. Okay, so the search key of the primary index is usually, but not necessarily, the primary key. Sometimes the search key of the primary index is considered as the primary key, but it is not necessarily for every time. Next one is the secondary indexes concept. In secondary indexes concept, an index whose search key specifies an order different from the sequential order of the file. Okay, meaning is that a secondary indexing concept is that is not similar to the primary index or not similar to the clustering index. That is a different kind of a things, that is quite different from the primary index, that is considered as the second clustering indexes. Non-clustering indexes meaning is that, for I am just giving an example, that you are maintaining a table. For example, so employee table. So in employee table, employee ID is the primary key. So for example, you are considering employee ID as the search key and maintain these values in your index table, and some pointer is assigned to fetch the individual records. Okay. Now the thing is that apart from this search key, apart from this search key, means apart from the employee ID, if you think that, for example, the enrollment number can be considered, sorry, the employee and the employee PAN number, employee PAN number can be considered as the another search key depending on the index file. So you are maintaining a separate index apart from the primary index, that is depend on some secondary search key or some secondary attributes, that is the employee PAN number. So in these cases, this particular type of index is considered as the secondary indexes. Okay, sometimes it's called as the non-clustering indexes. And the next one is the index sequential file. So the sequential file ordered on a search key with a clustering index on the search key. Okay, so these are the types. These are the types are there. And now the next thing is that is the dense index file. Dense index file meaning is that, dense index meaning is that, for example, index record appears for every search key. Index records appears for the every search key value in the file. For example, index and ID attribute of index and relation. Dense index files meaning is that is a simple example of the order index. Sorry, that is a simple example of the clustering index. Okay, here the dense index file is simply example of the clustering index. Here you can, I already give this example. One table is there. For example, the primary key is considered as the employee ID, and the same employee ID information is kept in the index file as a search key, and this particular search key value is directly connected with the each of the rows in sequential order. Okay, in sequential order we are connected that things. Okay, so that is a dense index files, and all the rows are connected in a sequential order. That's why sequential order means if each of the row are connected with the previous and connected with the next rows, then it is considered as the sequential order. So here the things are there. Here there is some, that is a dense index file is created, means a order index is created, that is depend on the department name. Depend on the department name we have created that things. Okay, so here some departments are connected. For example, biology have only single rows, that is not a problem. But if you are checking here that for the finance there are more than one rows, but only one single row is connected with this particular index file finance, means this particular search key have some pointer. This pointer is located to a single row only. Okay, so this is also an example that dense index on department name with instructor file shorted on department name. Okay, so these are the things about the dense index files. Okay, in next session we will discuss little bit more about this order indexes. After that we are focusing on B tree and B plus tree, and B tree and B plus tree will be covered by Srilekha ma'am, and tomorrow ma'am have some class in both of the sections. Okay, you must attend these classes. Okay, so for the time being I think that today these are quite sufficient for your memory. Okay, in next session we will discuss that thing in some brief way. Okay, so if you have any question, kindly send me the question in my WhatsApp number, and so that I can discuss that thing and resolve your queries if you have any queries still now. Okay, or those who already understand everything, I am just opening the quiz link. Complete your quiz within time. By 2 p.m. I will close the quiz link. Okay, complete your quiz before 2 p.m. Thank you, and if you have any queries, kindly send me the queries in my WhatsApp number. I will give you the reply through the YouTube channel or through one-to-one basis. Okay, thank you. I am opening the quiz link. No need to hurry. I am opening the quiz link. Okay, so those who are viewing, complete your quiz within time, and if you have any query, kindly send me the queries. Thank you.